Yes, my name is Mads. Now we got that solved. I work here at Trustpilot. Like I said, I'm a software engineer, like everyone else at our company. I work in something called the Business App Platform team with Paulo. We are a purely technical team. There's only 2 developers, and our focus is the business app, which is what I'll be talking about most of the talk today. And we kind of own the foundation of that technically. Make sure to drive it in the proper direction, and we have a big project at the moment where we're kind of trying to get it in better shape. That's what I'll be talking about today. I'm on Twitter and GitHub and Instagram. Cool. So the business app, it's the biggest product we have in Trustpilot. Most of you probably know Trustpilot.com. That's our consumer-facing website, and then we have business app or b2b.trustpilot.com, which is where all the customers that get reviews on Trustpilot go to manage a bunch of things. And there's millions of lines of code, or I don't know, there's a lot of code in there, and there's 29 modules, more specifically. A module is like a little sub-app within the app. An example is invitations, or the reviews management, or analytics, and there's 29 of those. They're being worked on by 10 separate teams here and in Vilnius. It's all Angular, or it was all Angular a couple of years ago. The app itself is this kind of a monstrosity that loads a bunch of other modules from, like, basically loading scripts over the network and injecting them and getting it all bootstrapped. So some of the modules are 100% Angular at the moment, but most of them we're slowly migrating them to React and Redux and this whole structure that we've been setting up. But our goal is not necessarily only to go to React; it's also to get to a better architecture where React is one of the tools we wanna use to get there. These modules work as the separate GitHub repos. You can clone them and run them locally as a regular single page app. But then when you deploy them, you just deploy like a JavaScript file and a style sheet, and that gets injected by the business app thing that will then do a lot of weird things to it. So basically, local and production is not the same, and that's maybe the biggest problem that we wanna fix. So what's wrong with it? It's a pain to work with it. It's a pain because everything is one big app. We don't have a lot of good error handling, so if there's one of the apps that fails to load, or where as it starts running, it has some kind of failure that was not thought of before, everything stops loading. Like I mentioned, we're 10 teams working on this. We have probably, I don't know, like 10, 15 deployments every day to one or some of the modules. So the risk of something happening is quite big, and every single error in the business app goes to me and Paulo because it's all one big app, right? Not so nice. Any runtime error will also kind of freeze the whole thing. Then we have these scoping problems. If you put something like a class name on something that is not thought through, if you have like a title on something class, then the odds of someone else having that title is probably pretty big. So we've seen a shit ton of problems with like CSS going out of whack for no apparent reason. Like you didn't change anything, but someone else somewhere did, and it's impossible to find because it's 1 out of 29 repos to look through, right? If you know anything about Angular, there's a thing called directives and something called constants, and those things also apparently are not scoped to a module. So if you have a directive or a filter or anything like that, it will also clash with anything else with the same name. We've had problems with configuration where whatever app was loaded the last would kind of control what configuration values were put in the app with interesting effects. It's basically pretty unpredictable, and it's very, very difficult to debug. We have up to 30-second load times because we have one app that loads 29 other basically full single-page apps that include React, include Redux, everything like this. It takes forever. There's no lazy loading. Like I said before, local dev and production are not the same. Routing is overwritten in production, so you think your links are working, then you put it in prod and it doesn't work. There are filters that just change when you put it in production. we have scoping problems in general. It's Angular 1.5, and we don't have any way to get out of it because everything is one big app, and if you try to upgrade Angular in one of them, everything will fail because everything depends on Angular being a global on the window object. So it does not work, and there's way too much code to just do like a one-to-one. Let's upgrade and hope for the best, because testing doing all the regression tests is impossible. Yeah. So what we're doing is microsites, because we want to get out of this problem. Microsites are where this is what we had before. We have a bunch of modules that are all loaded by this one app that then has a loading spinner because it takes 30 seconds, and then through that it's served to the network and the users. And we want to get to this situation instead, where a module is a whole app on its own. It doesn't have any shared runtime with anything else, because that's creating too much chaos for us. So an app is a repo in GitHub. It's deployed to AWS and S3 more specifically on its own. They have their own buckets, every single app. They act as separate websites when you run them. You'll go to an URL and you'll load only the analytics or invitations or whatever, and you won't load any resources for any other apps. They don't have any common runtime, as in you have the runtime of your app and not the other ones. And then to keep everything looking consistently outside of the main content of the app, we have something called an app shell, or we're building something called an app shell that is basically the left navigation and the top bar and all this kind of thing. I'll get back to that a little bit more as well. So why are we doing this microsite? Why don't we just have one big app? Well, we want to solve some engineering problems. We want to contain these errors that I was talking about. We want to have some kind of control over them and send them to the right people, or at least not break the whole app if someone has a mistake somewhere. We want to have the option of upgrading our stack easier. Like we want to be able to, let's say, React someday is not the most awesome thing in the world anymore. We want to not have to invest in a year-long project to migrate out of it. We want to have like an experience for the developers where they don't deploy something to production and have to test it manually in staging first to see that what they did is not weird, and afterwards do the same in production. We want to have an experience where your code in local is the same as it is in production. We think microsites will solve, the architecture we're trying to push should solve all those problems. But I think a very important thing that we've learned is that there's also something called an organization. And while we're very good at solving engineering problems, we had forgotten some of the organizational problems that needed to be solved as well. Our first initial thought was, let's just build one proper SPA that can load modules, and maybe they're Git submodules, maybe they're NPM libraries. Let's build some structure where we can do common chunking and tree shake and have an awesome optimized experience. And we pitched this to our management, all happy to just needed to be signed off, and we got a lot of pushback because all of a sudden we got into the situation where you have one app that someone needs to deploy manually at some point, and you need to make sure that all the other people are ready to have that thing deployed. And we even got into like discussing whether we needed to build our own deployment system, and it got a little bit out of hand. What we wanted to have, or what the management pushed us to have, is complete ownership in each module or each app to a specific team. So you have you own all of the code, you own everything that runs it, and the data and everything that gets in there. You own the deployment, the rollback, and you don't block anyone else with your code. Like if you have stuff that you haven't tested properly or don't have time to test over the next day in staging, it shouldn't block other people from putting their stuff in production. We want to have, basically the rollback thing was a big concern. And just having a shorter time from code to production, that the team can take that as soon as they're ready to deploy. They can deploy without worrying about other people or other teams. And I hope, I think I'm going to spend most of the time on this implementation details of it. I hope this was enough context about the business app. I could spend hours just talking about all the problems and all the ideas we had, but I'm going to go into a little, I think what we want to do with this talk is to give you some of the ideas from our architecture discussions because we couldn't find a lot of it when we were like looking for how to build this thing. So maybe this will help a little bit. There are 4 parts to it that, and disclaimer, we're not there yet. We're still working on this, and we have been working on it for half a year or something. So it's kind of a big project, being 2 people working on it with other responsibilities as well. But we're working on it. So there might be stuff that will change later or that we're not fully thought out. But yeah, I think we're pretty safe. There are 4 parts. There are the business app scripts, one big CloudFront distribution, something called the app shell, and then a service worker. The business app scripts is an NPM library that all the apps have installed as a dev dependency that is a glorified Webpack config with a lot of extra features. It's a bit hard to see on the screen, but it has like features for building, starting, analyzing, linting, testing, everything. So we have a consistent way to run all the applications across teams, meaning that as a platform team, we can make updates here, get them out to all the applications, and we know what the apps will look like when they're being built. This is a kind of a key to some of the parts of this microsite project, that we know what the HTML file that gets produced look like. So what it does in the microsite world is it builds it like a regular single-page application or a regular JavaScript React bundle, creates an index.html file with whatever an index.html file needs, but specifically it adds a few scripts that load some of the shared resources, so we control how that happens. And that is the app shell, and that is registering the service worker and communicating with the service worker. The CloudFront distribution is, yeah, if you don't know the logos, the one on the left is CloudFront, the 4 on the right are S3. They are different, yes. We have one distribution called Business App or b2b.trustpilot.com, and that one has like, what's it called, behaviors or origins that if you go to /dashboard, so you go to b2b.trustpilot.com/dashboard, we route that to a bucket called dashboard app. So that app has its own bucket. Same goes for all the other routes. So the app in the future is just a CloudFront distribution that fetches data from or fetches apps basically from the right buckets. Yeah, and it does the caching it needs as well. The app shell is this. This is the actual app shell, the one we've built. That the left menu, the top bar, including all the little features such an app has. It's both it's server-side rendered to be able to just, we have an endpoint that we give it a business user ID, a business unit ID, a locale, and some other stuff, and we get static HTML back that is like a fully rendered app shell. We built this with Next.js and like server-side rendered React, so we could use our pattern library and all these nice things. On this behind the scene, we also pass it an access token, some other stuff, so we can do all the API calls it needs to get all the information, get the notifications, the getting started menu, and all the strings in the right languages and all this stuff. And this comes back as static HTML, and we dump that in the DOM on an app. So an app will load this stuff, put it in the DOM, and then put itself in the middle of it. We also send client-side functionality with it. That's why we use Next.js, because we have static HTML rendered, but we also need some of these stuff, like you can click them and they open and you can filter into all these kind of things. That's client-side functionality that we send along as part of the payload. But the problem is if you have an app that does a network call to get this app shell and to get its own scripts, when you go from /dashboard to /analytics, for example, there will be like a page refresh, like you will get a blink on the screen, it will be white, and then it will load the next thing. And that's a problem, and we actually used to have that in the past. We used to have a less awesome version of microsites before we had this business app. So that's a concern that the UX is not good enough for that. And that's where the app shell model, as Google called it, like I think some of you might remember PWAs, they call it the app shell model, where you have an app shell which is stored as a cached object in a service worker, and then it's served very efficiently because you never needs to go to the network to get that app shell back. So switching from a server-side render page to another, or in our case, one single page app to another, it fetches this app shell, all this static HTML out of a service worker cache super efficiently, and you will never see anything change on your screen. It will feel like a single page application. So we have a service worker, and every time you go to /dashboard or something that looks like a page URL, the service worker intercepts that network request, and instead of going to the network and pulling out some index HTML from some CloudFront and S3 thing, it goes to the cache and sends back the app shell. And then the app shell now acts as a single page app that loads the next app. I've tried to put this in a model where you can probably understand a little bit better, but I'll get to that later. Google writes some stuff about this on the internet. Also, Jake Archibald from Google has like an implementation of this with called offline Wikipedia, which is a much more narrow and simple version where it doesn't have any dynamic data in the app shell, but it was a big inspiration for us actually. The service worker is running like this. Is actually, first I want to show what happens if you don't have the service worker, because that happens to all the people that are unfortunate enough to be in IE11 and below, and it also happens to when you get to the business app for the first time or a new browser, or you've cleared all your data, you don't have a service worker installed. This is basically what happens. You go to /dashboard or to one of the pages on the app that hits the CloudFront distribution I was talking about before, which goes back to the S3 bucket, finds the right index HTML, and then responds that to the browser. And by now we're just talking about any single page app in the world, right? Nothing fancy about it. It's served to the browser, which starts the app and gets it running. Meanwhile, while the app is kind of starting in the background and bootstrapping and fetching a bunch of data, we go to /appshell on b2b.trustpilot.com/appshell, where we have this endpoint located. So it fetches all this dynamic server-side rendered HTML. It mounts it on the DOM, so it gets a bunch of HTML back and puts it just in the body and like we split it up and put some of it in the head and some of it in the body. And then when the app shell and the app are both ready, we display the app to the user. So now they have both parts of the application. So not too crazy or anything yet. But at the same time, while all this is happening, so this is like a little bit of a simplified version of what I just showed you. While it's responding to the browser, we also install a service worker on your machine that behind the scenes will wait for this message that we call cache URLs. It's something we invented, that when the app is finished loading the app shell, we tell the service worker which URLs we loaded. It caches that app shell HTML and puts everything, all the assets like the fonts and the logo and all these other things, puts all those things in the cache, and then registers any URL that we say look like an app. So that's /dashboard or /analytics/reviews or like all these kinds of URLs. Register them in the service worker and say anything like this, don't go to the network. Use the app shell instead. So after that happened, you have a service worker. So you mean you've been here before. You go to /invitations, a new page, like you switch from dashboard to invitations. The service worker has now registered that looks like a page URL. It's not a static asset. So I want to intercept it in the fetch event. I want to respond with the app shell instead of going to the network. The app shell will be available now. Like now the user has a super fast like time to first paint. Like you have something on the screen with so fast that you don't see anything else happening. Meanwhile, we have this thing we call the load app routine that starts running, which will go to /invitations, that's the page we're going for, /index HTML specifically, because we want to get that HTML file that we know exists in this bucket, and we want to pull the parts of it out that we want, like the body mainly, also parts of the head, but mainly the body, and then we want to dump that on the DOM. So we already have the whole app shell, like half-finished application in the DOM, and then we want to take this body that we get and dump it in there so So we have a full application. And then now the whole thing is available. You didn't see any blinks. Sometimes the whole app shell is cached, so that includes that thing where it says your name on the top, that thing where you have how many notifications you have available, that it's in English or Danish or Swedish. If any of those things change, which they do sometimes, that's like the thing with dynamic data, we need to bust the cache, because otherwise you could change the language in one browser and then in this other one it will still be in Danish. So we use something called Workbox, it's a detail, but we have built a system where we send messages to the service worker to tell it that, like, I've clicked this button that said to update the business user. When that's done, we want to tell the service worker, we've changed some data, please refresh behind the scenes. So while the user is not looking kind of on a separate thread, it will start loading this new app shell with the same routine as it did before, and replace the cache with a new version of the app shell. And then it will respond back to the page to say, I'm ready now, and the page will switch out the app shell with what's now in the cache. And we do this for everything you change, whether it's language or anything else. When you install it the first time, we will also do a request to get the freshest app shell, because you might have been on one browser and then you change your language to Danish and then you went to another computer. We want to get the right language to the user. So behind the scenes, we'll be like trying to pull the latest always. But there might be situations where a user will, first time they see a page, it'll be in English, and the next time it might be in Danish. There are a few wrinkles here that we haven't quite ironed out, that we also like kind of need to see it more ready before. Like, it's kind of details that we expect to just fix in the iterations that come along. Yeah. Some of the potential problems that we're seeing might come up are, and we're obviously trying to mitigate them. Now we have a bunch of apps that are all completely separate, and they don't belong on any kind of shared runtime. They don't even have to be the same technology. You can have one in React, one in Elm, one in Angular, one 5 if someone wants it. There is the risk that the stack across the front end in Trustpilot will just drift completely, because when a team is autonomous and can make their own decisions, there is a tendency that they choose what they like. The way we're trying to mitigate it is to kind of decide what the paved road is, and that is React, and at the moment it's Redux and Redux Saga. And then we've told management, this is what we expect people to use, and they've said, unless you, if you need any state management, it's Redux. If you need any UI renderer, which you do, it's React. Those are the rules. At the same time, from our side, we're trying to help that along by building a lot of tooling around it. Like, we have a lot of libraries that make it easier to do tracking via Redux Saga, for example, or that bootstraps your whole application, and you don't have to think about where languages are coming from and all these other things for React. So if you want to make it easy for yourself, use all the stuff that we've built. If you have a really good reason for wanting something else, you'll be spending some extra time, but it's possible. So that's kind of our idea. We have had a bit of a fear of like a lack of consistency across the app, that all of a sudden you'll be having people building things completely differently. One of the ways we're mitigating this is a separate project that we've also been working on, which is a pattern library. So we're like building up our whole design system at the moment, and we're building a library with as many components as we can agree on. And the more we have of those, the easier it will be to just use those, and you have a consistent app. This library is written in React at the same time, so that will help the people across the teams use the same technologies. One thing we haven't solved is what happens to some of the apps that people don't work on that often. You will have apps that were written 2 years ago and it serves its purpose, and there's no reason to go back and revisit it. They might grow stale. We don't have any specific reason for anyone to go back and update anything in there, except it's a good idea. So that's a risk that is a little bit there. I'm not sure how big of a problem it is, but it is definitely a risk. It also requires that every single team has people in there that know how to build front-end applications, because there is a bit of tooling here and there, but at the end of the day, as a team, you own your app 100%. So any performance concern is on your own team. So you need to have knowledge about performance in your team. And it has to be pretty solid, because there's a platform team that kind of gets everything around it running, but there's no one that comes and helps you, like takes everything around your app and gets that to be beautiful and nice. Yes. That was it. Do you have any questions? We have time for a few questions.
You said that you have problems with scoping your CSS, and I guess you're just using CSS for your solutions. And are you thinking about changing that to use something like JSS or some newer technologies like that?
Yes. It's a discussion that hasn't settled yet, so I don't want to say too much. But we do have some, like all of our apps were originally using Sass, and most of them still, well, all of them still are. All of the apps have on the body, they have like their own class name. Like the name of the app is a class name on body. So if you scope it under that, it should work. And then sometimes it fails because people do stuff they shouldn't have. And our pattern library, for example, and the app shell that I mentioned before are both written with React Emotion, because we want to get out of this problem where we don't know who might consume this app shell and what they might be calling their class names. So we're definitely using Emotion for this type of thing. And there's a bigger discussion going whether we need to use Emotion everywhere, and what does that mean for designers who need to collaborate with us on our CSS, because we do have some designers that would like to clone a repo and change some values to make it easier for them and whatever. So that's an ongoing discussion. But definitely we've chosen to use some of the CSS and JS options where it's not an option to have scoping problems, like the pattern library. It's not okay to have a dot button, because anything can be a button, and you don't know which version that button is and all that. So for sure, we're using Emotion for that kind of thing.
How do you handle passing the cache in the service worker if you do an update to your app shell? I know you talked about if you change the language, or like the user changed the language or something, but I've heard people have had like troubles when they release a new version of their app shell or their app, as a whole, and had trouble and have the service worker serve the cached version of the previous version.
There are two different strategies for that. If it's a less critical update, if it's just some styling change or something that was nice to have, adding a new feature, whatever, I don't think we're going to do anything except let the cache wait until it gets stale on its own. So when someone does any change or visit a new page, because when you do visit a new page, we will always invalidate the cache and get the latest app shell, even though you might not see it immediately. You will see it on one of your later page requests. If it's a very critical change, we put a version number on our app shell, or service worker cache name, like a app shell cache v1, v2, whatever. And if we bump that number a little bit, the service worker or the browser will see that the service worker has changed the slightest, so it will throw the old one away and run the new one, fetch the new app shell, invalidate your cache. So those are our two strategies, and I think the last one probably won't be used that often. Because in most cases, the user will, like, if they go to the page, they'll see the old app shell. If they go to any other page, they'll see the new app shell. So the risk is not too big for us, because we keep doing that network behind the scenes always. Yep.
Have you considered TypeScript discussion?
Yes. Our business app script supports TypeScript, actually. We have a couple of apps written with three, I think, written with TypeScript. Some people prefer it. We have some very .NET heavy teams that pushed for it. At the moment, it's not part of like the paved road. Like we don't spend time supporting it as a platform team. Like we don't put typings on the things we do, but we leave it open for developers using TypeScript to send us pull requests with typings or update the loader in the Webpack config when it needs to. But it's not something that we as a platform team have an opinion on or have any like stake in. And as of yet, it hasn't been a discussion of whether we should be doing that instead of just ES. There was a discussion of whether we should have TypeScript or Flow if you wanted to have typing, and it was decided to use TypeScript for, I don't know, it's like a management decision. Just choose one, I think. Yeah, that's the furthest we've gone with that.
So I like the decision about bundling your development tooling into one dependency. And I've been down a similar path in the past, and I wonder, like, what's your experience? Like, what were the benefits and disadvantages of that approach, and how much configuration do you allow the teams to, like, how much do you allow to adjust the configuration for each team?
Let me answer the last part first. We allow almost everything to be overridden. So our Webpack config looks at another object, which is the config object. So we have like a loader for TypeScript, for example, that just references the config.typescript loader. So in your application, we have a config folder, and you can put a file in there that matches the environment. So you can put like a default.js or production.js and say that on production, I want to have these options be different for TypeScript or whatever. In practice, that happens very rarely that anyone needs to update it. The reason we keep maintaining it is that precisely what we have had problems with before, migrating from one thing to another. If you do want to try something new out, we want it to be possible to override some config instead of having to pull it out and put in your own Webpack config to be able to use CSS modules, for example, if that was the thing you wanted to try out. If we didn't have any configuration, that would have to be like a custom configuration. So we allow quite a lot of config. And I think like in the last couple of years, we've had pretty good experiences with this build script stuff. The early iterations were not maintained that well, didn't have like a clear owner, and they were gulp. And some of these things made it quite difficult to maintain. And there were a lot of problems that didn't get solved. But I think since there's been like, before us, there was another team that owned that as part of their context. And now we do. Since then, it's been a much smoother process. That there's a dedicated resources to it. Most of the time, we don't actually do active development on it as such, unless something big in the world changes. We listen to what people have. Most of the time, people come to us and say, I need this feature, or when I'm trying to use React hooks, the Oclify.js doesn't work for use effect, so we chose to switch that out. In this case, it was Tobias who did the pull request for us. So I think we had pretty good experience. I think the number one gain, like it's always like this cost of an abstraction is there, and the biggest gain we've had from it is that you don't have to worry about this kind of thing. Like we even went one step further and created something called Create Business App, where it's like Create React App or anything else. You run it and you get completely bootstrapped a folder with the structure that we usually see in business apps. Install the business app script and the panel library and some other things, so you can run this thing and get a checklist of what to do to get completely ready for production. And those two pieces of tooling make it very easy for anyone to create a business app without knowing all the little weird details that we would otherwise have to try to write out in a markdown document and remember to update and all this stuff. So that's our biggest gain from it. It's a bit annoying sometimes when, for example, we want to change our ESLint config or something like that. It has to go to be updated one place and then updated in the business app script and then updated everywhere else. And but I would say most of the time it's kind of worth the abstraction. Was that enough? Anything else? Last question.
A couple more questions. So you said that you want to make so that each team owns the app and the code. And what about the Amazon infrastructure? Is that owned by each particular team, or is it owned by a platform team?
Yeah, that's owned by us. And we have one open question there because it's a bit finicky to go in and change these origins, and you need to get things right. And how do you roll back and all these things? Our SRE team are looking into Terraform generally for us. And I think we would like to piggyback on that and get this whole Cloud Run configuration owned by us still. Like we would have the ownership and responsibility, but it could be a GitHub repo with with all of that config in code as in Terraform. So it would be send us a pull request if you want to add an app or change the URL of your app or something. So
what about the S3 buckets? Are they under a single Amazon account or they're different accounts?
yeah, all the buckets are in the same account, and anyone has access to everything. But we still say you own the bucket and all the rights to it and how you want to. And if you want to have your stuff in some weird folder in another bucket, that's fine. Just get it to work. So, good. Thanks. Thanks for that.